this is a short video on fractional exponents and radicals. So we're going to start out with what we know about square roots. So for example, the square root of 25 is 5, the cube root of 8 is 2, and if you're not sure where to get that cube root, it's under the math menu. So you'll see number 4 there will give you the cube root. So the cube root of 8 is 2. So we're going to use that information in just a moment to see what happens when we have fractional exponents. Okay, so what if we have 25 to the 1/2 power? So let's remind ourselves that the square root of 25 is 5 and the cube root of 8 is 2. Okay, so let's see what happens when we plug in 25 to the, now I need parentheses here, to the 1/2 power to tell the calculator that that whole quantity, 1 divided by 2, is the exponent. And I get 5. Aha! That's interesting. Okay, now how about 8 to the 1/3? 8 raised to the 1/3 power is in fact 2. So it appears that 8 to the 1/3 is the same, is equal to the cube root of 8. So the cube root is the same as the 1/3 power. The square root is the same as the 1/2 power. Now remember that there's a 2 that is implied here, but we don't write it, right? It's assumed to be there, but we don't write it. Okay? Well, let's see. So let's try these. So if the square root of 25 was 25 to the 1/2, what do we think we're going to rewrite square root of 16 as? Well, I know that the square root of 16 is 4, so I know that to start out with. So let's see, right? We think that there's a 2 here, so I'm going to try 16 to the 1/2 power and see if I get 4. So 16 to the 1/2 power is in fact 4. Excellent. All right, so if the square root is rewritten as the 1/2 power, and remember that the cube root of 8 was the same as 8 to the 1/3 power, what do we think the 4th root of 81 is going to be? I'm going to guess that that is 81 to the 1/4. So let's see what 81 raised to the 1/4 power is. Okay. Now my calculator says that that's 3, but I want to verify that that is in fact the same as the 4th root. So I'm going to go back to math and notice that, oh, I have a cube root and I have an x root. Well, okay, so let's see. I need to put in then the 4 for the 4th root and then go back to math and pick number 5. That will let me put in whatever root I want. 81. 4th root of 81, and let's see what we get. It says it is in fact 3. So I did a good job. I guessed that 4th root of 81 was 81 to the 1/4 power. Okay. So let's see if we can take this a little further. So here, what if we don't have a number? So we can't use our calculator to check whether or not we've rewritten it correctly. Well, turns out we can use our calculators to check whether or not we've rewritten it correctly. So first off, I'm going to guess that, again, the square root, there's a 2 that's implied there, is going to be the same as x to the 1/2 power. Now, how do I check that? Well, my calculator can graph things. So up here at the top, I've put in the square root of x, and in the second y, I've put in x to the 1/2. The other thing that I've done is, so that I can see it graph on top of it, is I changed the style of graphing here. And you can change that by hitting the enter button, and that will change. But I just want to graph these two. There's the square root of x. There's x to the 1/2, right on top of each other. So I have verified that that is in fact correct. Okay. Now how about this one here? How about x minus 5, the cube root of it? Okay. Now it's not just x, but it's x minus 5 to the 1/3 power. So I want to indicate that the whole quantity is raised to the 1/3 power. Okay. So again, I can go back and I can check that by graphing. So I'm going to turn off that graph and turn off that graph, and now turn on the cube root of x minus 5 and turn on x minus 5 to the 1/3 power. So I'm going to graph these two here. So let's see what happens. Okay. There's the cube root of x minus 5. And there's x minus 5 to the 1/3 power. So I did a good job. Excellent. Let's see. Try another one. All right, let's rewrite using fractional exponents, then check. So I'm going to turn off that graph there, turn off that graph there, and turn on the square root of x to the 5th. Okay, so I got that one turned on. I'm going to turn on this other one too. So I'm guessing, so this is x to the 5th. So I'm going to write this as x to the 5th and the square root to the 1/2 power. Well, what happens when we have exponent raised to an exponent? Can we simplify that at all? The rule, if we recall, is when we have an exponent raised to an exponent, we multiply the exponents. So this is the same as x to the 5 times 1/2, or in other words, the same as x to the 5 halves. So I'm going to check that that is in fact true. So I have the square root of x to the 5th, and here I have x to the 5 halves power. And I'm going to graph that and see what it looks like. There's the square root of x to the 5th. There's x to the 5 halves power. Excellent. Okay, here's another one. X plus 3 squared. So I'm going to guess that that can be written as x plus 3 squared to the 1/3 power. So that'll be, raise that all to the 1/3 power. And by using the same rules as above, I can rewrite that as x plus 3 to the 2 times 1/3 or 2/3 power. So again, I'm going to go back to my graphing calculator, turn off those two equations, those two functions, sorry, and turn on the next two. And let's see what happens. So again, I've put in the cube root of the quantity x plus 3 squared, and I'm graphing x plus 3 to the quantity 2/3. And again, I'm going to check to see if I get the exact same graph. So here is the cube root of x plus 3 squared, and there is x plus 3 to the 2/3 power. Sure enough, they're the exact same graph. Okay, so we've got two more here. Now we're going to go in the opposite direction. These are written in fractional form, and we're going to convert to radical notation. So x to the 1/6, x to the 1/2 was the square root, x to the 1/3 was the cube root, x to the 1/4 is the 4th root. So x to the 1/6 should be the 6th root of x. So let's check that out. X to the 1/6, and there's my 6th root of x. So remember, we can get the 6th root by first pressing the 6, then going to the math menu, right, and choosing the xth root. So I'm going to select that, okay, and graph and see that I get the same thing. X to the 1/6, 6th root of x. I did in fact get that correct. All right, so the next one here, I have x squared plus 1 to the 5/3. So we've been noticing that the number that's down here in the denominator ends up being the root. So one way to remember that is the denominator is the bottom part of a fraction. The root is the bottom parts of a plant. So the bottom part of the fraction is the root. So the 3 in this case is going to be our cube root. And what is it going to be the cube root of? Well, the rest of it. The x squared plus 1 to the 5th power. Okay. So notice I have an extra set of parentheses there to indicate that everything inside there is we're taking the cube root of it. So there's x squared plus 1 to the 5/3, and here's cube root of x squared plus 1 to the 5th. So they are in fact the same. So when all is said and done, we have a rule relating fractional exponents and radicals. that if we have anything raised to a fractional power, m over n, n, which is in the bottom part of the fraction, roots are the bottom parts of the plant, so that's going to be our nth root of a, and then we keep the mth power. So remember, the n is the root, and then we just use the rest of it as the part under the radical.